In this video, we're going to be looking at the second page of the review, starting with problem 13. It's asking you to figure out the points x and y on the unit circle that corresponds to the given angle. So you're given the angle, you just need to figure out the coordinate points. So if you have negative pi over 4, here is the starting. So if that's where pi over 4 is positive, then negative pi over 4 would be right here. It'd be equivalent to like 7 pi over 4. So in this case, this is going to be my coordinate. So that is root 2 over 2 for x and negative root 2 over 2 for y. So we're just finding coordinate points. This one is 3 pi over 2, and as you can see, 3 pi over 2 is right here, where its x is 0 and its y is negative 1. And last here, 15 is 17 pi over 6. This one's a little tricky, but I want you to write this as a mixed fraction because it will really help you out. So if you think about it, 16 goes into 17, 2 over, let's see, that would be like 12, left over is 5 pi over 6. So this has already gone around the unit circle one time already because this is 2. So it's already gone to 2, 0 to 2 pi. So it's gone all the way around. And then there's 5 pi over 6 left. So it looks like it lands back to here at 5 pi over 6 with a coordinate of negative root 3 over 2 and 1/2. So anytime you have a really big numerator, or what we call improper numerator, or improper fraction, then write it as a mixed fraction. See how many times that number in the bottom goes into the top, and that will help you figure out where you are going to be on the unit circle. So for this next problem, you're going to need to be using the unit circle to find the exact value for the given trig function. So we might need to refresh on this, but using the unit circle, whenever you have cosine, that is going to be equivalent to your x value on the unit circle, and sine is your y value, and tangent is the one that is y over x. So I thought I'd just remind you guys, and then secant, cosecant, and cotangent, we'll go over those when we get there. Now for cosine here, we're trying to find negative 3 pi over 4. So if we go to the unit circle, at positive 3 pi over 4 is right here. So negative would be going the opposite direction, and that would be equivalent to 5 pi over 4. And so my x value there, if we kind of pull up the unit circle for a moment, at 5 pi over 4, which is also equivalent to negative pi over 4 if we go this way, my x value is going to be negative root 2 over 2, it looks like. That's my x value. For the sine here, we have 7 pi over 6. And that would be located somewhere right here. Here we go, 7 pi over 6. And we need the y value, which is negative 1/2 there. So negative 1/2 is my sine value. The next problem here we have secant, and secant is the reciprocal for cosine. So the formal formula for secant is going to be 1 over x. And I'm going to zoom into this problem here. So for secant, we have negative pi over 6. So positive pi over 6 is right here. Negative would be down here. So negative pi over 6 is equivalent to 11 pi over 6. And our x value there is root 3 over 2. So that means that this would be 1 over root 3 over 2. If I were to work this out, this would give me 1 times 2 over root 3, because I would try to flip this fraction on the bottom, keep the 1 still, multiply straight across. This would be 2 root 3, but can't have a denominator of a root, so we're going to rationalize it. And this would give me 2 root 3 over 3. So that one took a little bit of work, but I eventually got there. So this next problem has tangent and it's 5 pi over 6. And tangent is y over x. In this case, if I look for 5 pi over 6, let's go ahead and try to change that to a mixed fraction because the numerator is quite large. This is an improper fraction. So 6 goes into 15 2 times. So this has already made one revolution around the circle then. And that means you would have 12 pi over 6, which gives you 3 pi left over for 6. And if we think about 3 pi over 6, 3 pi, or 3 over 6 can be reduced to, so this can be reduced to 1, 2, and 1/2 pi. So if you went one full circle around to get to 2 pi here, 2 pi, and then go another halfway from the 0. So if you went half, you would land here at 0, 1. So that means my x here is 0 and my y here is 1. So I'm going to put y as 1, x as 0, and this ends up being, well, 0 in the denominator means that this is undefined. All right, let's try out our next one here. So for cotangent, this is 5 pi over 6, and we've done 5 pi over 6. It's right here. And so whenever we have 5 pi over 6, our y value is 1/2, and our x value is negative root 3 over 2. So cotangent is a reciprocal of tangent, so that's going to be x over y. So my x here, again, was negative root 3 over 2, and my y value here is 1/2. So if I were to work this out here, this would be, the numerator would stay the same, but the denominator would flip. So then the 2's would cancel because they're diagonal. And if you multiply straight across, this would give you just, negative root 3. The 1 on the denominator, if you put this over 1, it just ends up being itself. So this is just negative root 3. This next one is cosecant of 45, and that's reciprocal of sine, so this is going to be 1 over y. My y value here, if I look for 45 degrees, is right here, and my y value is root 2 over 2 on the unit circle. So if I were to take this denominator and flip it, this would just end up being 2 over root 2. Let me just shrink down this unit circle if I can. Maybe I can't anymore. Ooh, that's going to be in the way. Oh well. So then this is 2 root 2. And so I'm going to rationalize the denominator. And this would give me 2 root 2 on the top and then 2 on the bottom. But then the 2's cancel. So this is really just root 2 as my final answer. All right, so secant here is pi over 3. Pi over 3 is right here. So secant is equivalent to 1 over x. And in this case, my x here for pi over 3 is 1/2. So I have 1 over 1/2. And so this would end up being 2 over 1 if I flip the denominator. And 1 times 2 is just 2. And then I would just have a 1 on the bottom, which ends up just being 2. So secant of pi over 3 ends up just being 2. Cotangent of pi over 3 would be, let's see, cotangent is x over y. My x here is 1/2. And my y here is root 3 over 2. So if I take the 1/2, hold it still in the denominator, this root 3 over 2, I'm going to flip it. It looks like the 2's cancel. And then I have root 3 in the bottom, so 1 over root 3. So I'm going to rationalize the denominator by putting a root on the top and bottom. And so this makes it root 3 over 3. And so that there is my final answer. Okay, so that there is all of those exact value trigs where you're using the unit circle. So make sure you know how to read a unit circle. So for this next part here, level 3, we are going to be talking about determining the quadrant that satisfies the condition. This is where we go back to using that coordinate system that shows positive trig functions. So we have the first quadrant, the second quadrant, the third quadrant, and the fourth. And I use that acronym, all students take cash, to help remember which ones are positive in the specific quadrant. But just as a reminder, the A stands for all, the S stands for sine and its reciprocal cosecant, tangent stands for the T and its reciprocal cotangent, and C stands for cosine and its reciprocal secant. So this might be helpful when you're working out these problems. So this one here says sine is greater than 0, so that means that sine is positive. And sine is positive in the first quadrant, where all of the trig functions are positive here, and sine is positive in the second quadrant. So quadrant 1 and quadrant 2. As for this one here, this says tangent is less than 0. So that means tangent is negative here. So let's ask yourself, where is tangent positive first? So tangent is positive in the first quadrant and the third quadrant. So it's negative in the second quadrant and the fourth quadrant. So second quadrant and the fourth quadrant. So I'm asking myself, where is it not positive? And it looks like it ends up being the one that match is the second quadrant for both conditions. So the second quadrant here is going to be where our trig function is going to satisfy. This next one here says that cosecant is less than 0, so that means cosecant is negative. And then this one says that cosine is less than 0, so cosine is also negative. So cosecant is negative, let's see. Cosecant is the reciprocal of sine. So sine is positive in the first quadrant and in the second quadrant. So cosecant is negative in the third and the fourth. For cosine, it says it's less than 0, so cosine is negative. Let's see, cosine is positive in the first quadrant and in the fourth quadrant, so cosine is negative in the second quadrant and the third quadrant. So it looks like the winner here is the fourth quadrant, because that's where both conditions show up. So the fourth quadrant is where they are satisfying the two conditions. All right, in the next problem here, we are trying to find two solutions of the equation. So you're given a trig function or a trig equation, and you are asked to find two solutions, give your answer in radians. So if you're giving your answer in radians, that means the two solutions here you're finding are the angles. And this helps if you have a unit circle. So I'm going to grab a unit circle here to help us out. There we go. So this one says tangent is equal to 1. When we're looking where tangent is equal to 1, we're thinking about, tangent being y over x. So when I put y over x, I should get 1. Well, that only happens when the top and the bottom happen to be the same, the same number on the top and the bottom. And the only numbers that does that is when it's root 2 over 2 for both x and y. So this narrows down our search. It could be one of these 4 areas. But what I need to understand is this is a positive one. So I can't use the second quadrant or the fourth quadrant because one of them is a negative. But the first quadrant I can use, if I put root 2 over 2 over root 2 over 2, this is going to give me 1. So this satisfies that condition. So my angle here works at pi over 4. But it also could work at 5 pi over 4 because both of these are negative. If I put them on top of each other for y over x, this would end up giving me a positive 1. So looks like 5 pi over 4 works for both to satisfy tangent being 1, positive 1. This next one here says we have cosine and it's equal to negative root 3 over 2. So cosine is equivalent to the x value on a unit circle. So if we look around here, any x value that has a negative root 3 over 2 is going to be on this side because that's where x's are negative. And so we can see that that is at 5 pi over 6. 5 pi over 6 has negative root 3 over 2. And then it looks like at 7 pi over 6, it's also negative root 3 over 2. Okay. And then let's take a look at our next problem here. So for 28, it says cosecant is negative 2. So cosecant is equivalent to sine, but it is the reciprocal, so it's 1 over y. So sine is equal to y, but cosecant is 1 over y. If that's the case here, if I want to know what this is on the unit circle, it might be helpful if I change this cosecant to a sine. So if I want to change it to a sine, all I have to do is flip this. So if this is negative 2, I can also see this as negative 2 over 1. If I flip it, it would be negative 1 over 2 for my sine. So I'm changing this to sine to make it a little bit easier to read on the unit circle. So I know I'm looking for a y value that equals negative 1 over 2. So negative values for y's are down here. And the first one is at 7 pi over 6. Because in this case, we have a negative 1/2 for y here. And then the next one here could be at 11 pi over 6, since the y is also negative 1/2 there. And that's it. So it looks like these two are my angles that I have that satisfies cosecant negative 2. So for problem 29, you are trying to find the angle given that cotangent is root 3 over 3. You could change this to a tangent, but I don't really think that would make it any easier. If we just think about what cotangent is, it's your x over y. It's the reciprocal of tangent. So what we have to think about when we take x and we divide it by a y value somewhere on the unit circle, we get root 3 over 3. So we're going to have to play a little bit. But what I know is it can't be any coordinate that has a root 2 over 2 because that would make it a 1. So I don't want any of those. I also notice it's a positive number. So the only place that cotangent could be positive is the first quadrant and the third quadrant because these two quadrants, the second and the fourth, have one negative sign, whereas these either are all positive or both are negative to make that value positive, overall positive. So I know I'm either in the first or the third quadrant. Now thinking about it, I want the top to have the root 3. And just thinking about how that could happen, maybe if I chose pi over 3, I'm just choosing something from the first quadrant just to keep it easy. So pi over 3 has an x value of 1/2 and a y value of root 3 over 2. So if I were to use this here, my x would go first, so 1/2 over my y, which is root 3 over 2. So I would have to flip my denominator, so that'd be 2 over root 3. The 2's would cancel, and then I'd be left with 1 over root 3, but then I have to rationalize the top and bottom. This would give me root 3 over 3, and this works. So that tells me I just now have to find something that looks like pi over 3, where I have a positive 1/2 over 2, and for the x, and for y, I have root 3 over 2. And so the only one that looks kind of like that is 4 pi over 3. Because in this case, this one is a 1/2 for x and a root 3 over 2 for y. Even though they're both negatives, it's fine because when you divide, they end up being positives. So the angles that work here is pi over 3 or 4 pi over 3. All right, that is it for this video. In the next video, I'll go over level 4.